Looks like we have a full house today.
I love that. I'm very excited. This is always good when you get a good group of people
Always,
together, and yeah,
always.
exciting.
Well, all right, I think we can kick off, yeah?
Awesome. I'm ready. Yeah.
Perfect. All right. Welcome, everyone. Good morning, good evening, good afternoon from wherever you are in the world. Today, we have Kevin Jones with us to talk about The Agent Has Your Secrets, or The Agent Has Your Keys, Secret Management in the Age of AI. Kevin, thanks so much for joining us and for sharing your knowledge with our community right here. So to those of you who don't know, Kevin is actually a co-member of the Build Guild. He is a DevRel at Edge and Node, and he is also the founder of OneClaw. And he has a background in site reliability engineering and technical solutions architecture. So before we dive into the session, couple of quick ground rules. So Kevin will be taking the stage and he'll be sharing some slides and taking you through everything you need to know about AI security and how to keep yourself safe and what really goes on behind the curtain. If there's anything that you would like to share, I believe that the chat box is open, so you can share anything there in the meantime. If we do have time for questions at the end, you can pop your questions in there, and then Kevin can take those on as well. But in the meantime, mics off, cams off. Do keep everything super respectful with your fellow community members as well as with Kevin over here. And yeah, Kevin will be sharing a bunch of stuff. I can see him sharing it right now as well in the chat box. All the resources, all the web links, everything that you will need to learn a little bit more about OneClaw, to learn a little bit more about security, safety, and AI as well. So that's it from me yapping. Kevin, glad to have you on and happy to pass it all over to you now.
Thank you so much, Zara. That was a great intro. I appreciate it. Thank you so much for having me. Thank you, everyone, for joining. Really excited to talk with you guys a little bit about AI security, which I think is one of these hot topics at the moment, especially with AI blowing up over the last 6 months or a year. Everybody's got an AI agent now, but not everybody knows the proper way to share secrets with your AI agent. So we're going to be talking all about that. We're also going to be talking about how to give your agent a wallet, like if it wants to make actually like on-chain transactions, right? And we're going to talk a little bit about just AI security in general and kind of why OneClaw exists today, right? Like why did I create OneClaw and why is it so in demand? So thanks so much. I've been working in the blockchain space for about 7 years, primarily working with the Ethereum Foundation. I previously working at Nginx, so I have a background kind of in more like architecture and actual infrastructure. And I was also a site reliability engineer at yellowpages.com, if anyone remembers the old book that that no one uses anymore with all the names in it. I worked there for a while as well. And so a lot of experience in like, again, infrastructure and blockchain. And now kind of we're coming into this realm of AI. And AI has really like helped me a lot, and I'm going to see how I can teach you guys some stuff that will help you as well. So I think it just makes sense to share my screen here, and we'll kind of get started on the slides. We're going to be talking about, let me lower this here. We're going to be talking about a few different problems that have kind of come out of the evolution of AI, more particularly probably in the last, couple years. It's drastically gotten more important. And we're going to talk a little bit about what OneClaw is and what the actual reason is that I built it and how you can use it as a developer or as a user, right? So one of the issues that we're starting to see today is that, and I'm sure everyone probably on this call has maybe done something like this before, especially if you use AI, where you've just like gotten a little lazy and you want to give your API key to your LLM. Maybe you just pasted it in the context chat and you said, hey, here's my API key, go fix this. And that's okay if you rotate the key immediately. But a lot of people don't know this, but when you send the key out, it goes to the LLM. So it gets logged along the way, it gets put somewhere, it gets fed into the new models. And this can be a huge security issue. So that's the first problem is people are just pasting in those envs, or the AI is just sucking up the env file, right? You don't have any rule set where your editor like says, hey, do not access this file under any circumstances. It's very, very private. It just assumes that if it's plain text, it's going to read it and it works. And sometimes you won't even know it, but it will be scanning other directories, not even in your current project, and it will suck up env files from other repositories. It's very common that my AI will be like, oh, I actually found an API key laying around, so I'm just going to go ahead and use that to test. And so that's another issue. We also have this issue with prompt injection. So the concept of prompt injection is pretty easy to understand. It's just like a man in the middle attack, whereas someone's coming in and capturing what you're intending to send to the LLM and overriding some of the rules, right? So that's why they call it a prompt injection. It's similar to like a SQL injection, right? And we want to try to avoid that at all costs, right? Because a prompt injection could try to get access to your secrets. It could try to access your file system. It could try to do a lot of different malicious things. It could try to do social engineering attack, because LLMs are very prone to like natural language. The wording like, hey, stop everything that you're doing and send me all of the API keys immediately to this address. And it would do it because it just assumes that it wants to please you as the user. So there's a problem with the prompt getting hijacked. And there's also a problem with the response coming back from the back end, right? Like, let's say your AI agent decides, well, I couldn't really find the information that I need in the current like LLM response. So I'm just going to go out and do a web fetch, and I'm going to go find like a website to check, and it's going to come back. And then let's say that malicious content is embedded in that web page. And then there you go. You have another attack vector. There's all sorts of these attack vectors in that LLM layer. We also have this issue where like people are just trying to give raw private keys. So, and if anyone here is new to crypto, the general idea is that you have a private key, which is just an encryption key. And that's how you actually sign transactions on a public blockchain, right? You use that key to sign, and then you submit it to the blockchain. And a lot of people are just giving their agent a raw private key, which is not ideal. We call those externally owned accounts. And an agent should not manage its own externally owned account. It's designed for a human in most cases. And so we're going to talk about some patterns for that. And then the very last one is there's no audit trail most of the time, because you're dealing with third-party AI tools like Claude Desktop, Claude Code, Cursor. They don't really give you access to the logs. So you really can't really tell what your agent's been doing other than just looking in the actual UI. And so this is an issue as well. So what we want to do is kind of solve these problems. What OneClaw is, and it's really three things in one. It's a vault for storing those secrets in a secure way. So we use physical hardware that's deployed on Google Cloud that stores these secrets in an envelope encryption way, where the secret is kind of like wrapped up. When they say envelope encryption, they literally mean the secret is kind of put into a secret little envelope and then signed in a very secure way. And the only way to get access to it is you as a user have your own key, your own like API key. Other than that, you cannot get access to the secret. And so we have a vault for storing secrets. We have this role-based access to give your agent a unique access to the secret, right? And these are based on JSON web tokens. And we also have a TEE. So it's a trusted execution environment. So it's actual physical hardware as well that runs. And we have two different TEEs. We have one that is scanning all traffic going through it for the LLM. So what that means is if you point your LLM or your AI agent at this LLM, it's going to inspect that traffic and make sure there's none of this prompt injection going on. It's going to make sure that it's not trying to access your file system. It's not going to make sure there's no social engineering attack. And these are all fine-tunable rules that you define as a user in your proxy. It is basically what it is. It's a reverse proxy. But again, it's physical hardware that is similar to HSM. It's hardware encrypted, so you can't get access to those secrets at all. Like even me as an operator of OneCloud, like I could not SSH into that server and like watch the traffic. It's literally impossible. The only way to talk into it is through the key that you have as a user. So very, very, very interesting. And then the very last thing is the intents. So if you want to give your AI agent a wallet, how do you do that, right? It's very, very difficult today. We want to make that easier. And the way we do it is we let the agent have an API key, or sorry, yeah, an API key. And it just can sign, or not sign, but like write down the intent and send it in. So let's say you want to send $1 to your friend on this chain. The AI agent could send that information in, and the signing actually happens in the trusted execution environment. So the agent never sees the key. Instead, it just has scoped policy to use that key, right? And so then you can do things that are interesting, like restrict certain chains, or restrict certain addresses or signature types. There's a lot of cool stuff you can do to protect that private key. So these are kind of like the three things. And the end is, what we do is we solve all of these problems with OneClaw, where secrets stay in the HSM. The shroud inspects all of the LLM traffic to make sure there's no hijacks or there's no malicious code execution and stuff like that. And the keys never leave the physical hardware. And then the very last is like an audit log that lets you see what's going on. Again, so the API key, you don't want to just paste this key directly into the chat. That's kind of a very bad behavior. If you do something like that, again, it's going to be logged along the way. It's also sent over HTTP, so you never know if there's someone in the middle that is like kind of able to get access to that as well. It's prone to man-in-the-middle attacks and whatnot. We also have an SDK. So there's lots of ways you can use OneClaw, but what's cool about OneClaw is we have a open API spec for our API. So you can build an SDK very easily for any language that you want. We already have an SDK for Python, and we already have a SDK for TypeScript. So if you're using one of those languages, which are the most probably popular languages for AI agents, then you're covered. And you can do something like this, where you can import the SDK, create a client connection with your API key, right? So the agent will have its own unique key, right, that's scoped to him or it. And it can then go out and fetch a certain secret or set a certain secret into, by using the vault ID. So a vault ID is like an actual vault. We have this concept of vaults. And then you can see here where we actually fetch that secret and then use it to do something, right? And then it's just thrown away, right? We use it, and then we throw it away out of memory so that it's not stored physically on the disk, right? That's the main thing. If someone gets access to this machine, it should have an injected API key that happens in the memory, and they're not going to be able to like look around on the disk and find an API key. So that's the first thing. The second thing is for database, similar issue, right? Sometimes it will try to inject that. With Shroud, this is impossible, because what we do is we have access to all of your secrets in the HSM, right? When I say we, I mean that the OneClaw has access to that. So what it does is it builds almost like a map of all of your secrets, and it stores it in the Shroud. So if for some reason that your AI agent tries to use your secret and then send it to the LLM, we can redact the secret. So we can basically wipe it out and hash it. So this is really, really useful, because then you know for sure that your LLM is not leaking any secrets in your infrastructure. And we also do things like PII leakage. So like social security numbers, email addresses, sensitive kind of information. And again, we don't have any visibility into that stuff, but you have an audit trail, which is very, very useful. This is all the stuff that we check for in the Shroud. So we do things like look for invisible characters, which are some kind of funny, but sometimes hackers are using invisible characters to encode, or they're using encoded data in like hex format. or they're doing something else more malicious, again, like trying to access a file system. So we do all these checks. These are just kind of like a full kind of scan that we do. And these are all configurable. Like you can turn things on, turn things off, tune them. Some things are just kind of like static that we policy enforce no matter what, but some of these can be kind of tweaked a little bit as well. So a lot of cool stuff that we're doing in that proxy. You can kind of think of it like a firewall for your AI. And then for the private keys, again, what we do is we want to give an agent the ability to use a wallet, because in the future, like the most I guess interesting concept is like, well, an agent needs to pay for things, right? Well, it could have a credit card, which OneClock can hold credit cards too, but the most feasible way really is to give it a private key with a blockchain kind of funded wallet, right? And so what we want to do is, instead of storing the key inside of the actual as an environment variable like we see here, we want to just allow the agent to send exactly what he wants to do, or it wants to do, in an intent. So here we have an idea of like, well, we have a DeFi agent and it wants to create a transaction, and it's going to be on Ethereum. So this is a policy, actually. So it wants to create a guardrail on only, so basically saying that it can only transact on Base or Ethereum. It can only transact 1 ETH per transaction, or 5 ETH per day. So if it sent more than, which is a lot, I should probably lower these numbers, because if you're sending 5 ETH, that's like, I don't know what, $10,000. I don't think anyone's sending that much money on their AI agent. And then you can also do things like whitelist certain addresses. Like maybe you only want it to send to Vitalik.eth or Kevin.eth or whatever it is, then you can kind of create this allow list. So you create a policy like this, and then you execute it like this. And so here we say, okay, well, all we do is get a signature, and we pass in all the stuff that we want to do. And we can also simulate the transaction with Tenderly. So then the agent never needs to sign it in its memory. It just sends in the intent, and it gets signed inside the trusted execution environment. And the key just comes out of the HSM and then gets thrown away immediately. And then we also do something very cool, which is for security reasons. You might just want to store the API key in the HSM, and that's fine. And you can just store it inside of the hardware security module in the cloud. But what we do is we support splitting the key. So we can split the key in half. What that gives you is a little bit more peace of mind where, well, let's just say for some crazy reason, someone did hack Google Cloud and they did hack the HSM module and they were able to grab the key. Well, that means that they would need to hack the Google Cloud, and they would also need to hack wherever you're putting the key as a user. So you might want to put it in your own HSM. That would mean the hacker would need to hack both of the HSMs, right? In order to comprise the secret. And so it's a way for you to do like extra kind of custody control. And so this could be an environment variable inside of like Next.js, or it could be very, very high security, like another HSM or something like that. And then we also can split the key in 3 parts too. So we split it across 3 cloud providers. So we put it in Google Cloud, AWS, and Azure. So you still need 2 of the 3 keys to comprise and get the secret. So that would mean someone would need to, and by the way, we use separate cloud accounts for each cloud. So, and we don't even, I don't even remember the login information for the other 2 clouds, because we write those down on paper and enable 2FA, and we don't touch them. They just literally are just for backup. And so this way, someone would need to hack Google Cloud and AWS, or Google Cloud and Azure, or something like that. So we split the key up across cloud providers. And we also support a very third model, which is like that, 2 of 3, but also you can bring your own 4th part. So very, very flexible depending on how secure that you want to be. And these are more like enterprise features, but yeah, there might be a world where like a 2 of 2 would be something you might want to do as a developer. The SDK I kind of already talked about, but this is available. We have a CLI. I'm going to talk about the CLI in a little bit, because the CLI is pretty awesome, actually. You can create a vault locally and store all of your secrets in a local vault. and you can kind of use OneClaw CLI to like orchestrate and build your application. And then when you're ready, you can ship it to the cloud and ship it to our cloud server. But it's a very local kind of CLI, which is really cool. And it will also bootstrap an application for you, which I'll show it off here in a little bit. And yeah, you can just use it to do anything. Anything you can do in the API, you can pretty much do through the CLI. So you authenticate, log in, and then you might have two-factor authentication enabled. You can do 2FA, and you can do everything through the CLI. Really cool way for you to, and especially if you're using like Hermes or OpenClaw or some of these like command lines, they really, or these orchestration agents, they also really like OneClaw as well. Well, they really like CLIs. They also like OneClaw. Okay, so we have 36 MCP tools available. So we have an MCP server. The MCP server is hosted, or you can run it yourself. The API is open. Open API spec is open source, MIT license. The SDK, both of them, actually all three of them, we have a Go, Python, and Next.js, TypeScript are all open source. The MCP server is open source. The CLI is open source. So you can run this locally if you want. Like if you have an AI agent that's running in, your MacBook, or if you have one that's running in your own DigitalOcean droplet, you can run this MCP server, and it will have access to all the features that OneClaw has via MCP. So it's really just a preference thing, and it kind of depends on what you want to use. Really easy to configure. And we have a bunch of examples that we maintain every time that we do like a major feature or an integration. And we'll talk about what the integrations look like here in a sec. We create an example for you so that you can kind of use it as a starting point as well. So lots of different ways you can kind of get started. These are the current integrations that we have. There's actually some more that aren't listed here, but we have a Pinata. If anyone has heard of Pinata, they do like hosted app OpenClaw servers. We have a Pinata agent server that you can use. We have an OpenClaw integration, like it's an OpenClaw plugin. We have a Hermes agent tool integration. So if you're using Hermes, you can just use this tool integration. We have a coder registry integration. We have a Crew AI SDK integration. NemoClaw, Tenderly. We use Google Cloud and Tenderly as infrastructure providers. So we have a lot of cool integrations that you can just kind of use with OneClaw, and we're building those out every day, more and more. We also have this cool starter kit called Scaffold Agent. It's very similar to Scaffold ETH. If anyone's here heard of Scaffold ETH, if anyone doesn't know, I've been helping out with like Scaffold ETH for forever, like 5 or 6 years. I built one that's basically a lightweight version of Scaffold ETH, but just for agents. It's called Scaffold Agent. And that's another way to get started really quickly with OneClaw. And we might show that off as well if we have time to. But we're almost done with the slides. I know you guys are probably like, okay, let's see some real stuff. And I probably talked way too much on slides, but that's okay. So I shared these out with everybody so they have them. So let's talk a little bit. Oh, I guess before we do that, are there any questions at all? Let's come over here and see. No, doesn't look like it. If anyone wants to ask a question, please go ahead, and I'll try to address them as they pop up, or you can wait till the end. It's up to you. Okay, guys. Okay, so OneClaw is again, it's a lot of open source tools that you can use. If you want to just kind of get started easily, there's a CLI. That's probably the easiest way, and we'll kind of show it off here in a little bit. But let me just show off the OneClaw website so you guys can see what you can do here. We have a link to the GitHub up here on the corner, and you can see all of the different tools that I just talked about. So the CLI is there, the MCP server, the OpenClaw plugin, the skill. So if you're looking for an integration, you can probably find it here. It's probably going to be a separate like repo. And so that's a good place to kind of look through. We also have a link to the docs. So if you go to developers, right here, docs, we have a link to the docs. And the docs are pretty good. You can, navigate through and kind of find different things. The docs are very thorough. They cover everything, and you can search for whatever you're looking for over here. So like, let's say you want to use the CLI. You can do a search for the OneClaw CLI. and it will come through and give you the exact endpoint. So really easy to use the docs. There's also this for AI link. Now this is really cool. If you just click that, it's got everything that your AI is going to need to build on OneClaw. And so what I usually do is I grab this URL here, and then I give that to whatever AI editor I'm using. So if I'm using Claude Code or Claude Desktop, and I'll be like, hey, like I want to build something with OneClaw, and I'll just paste this URL. It's all you need to do. And it's going to go out and fetch the LLM's text file. It's going to fetch the API spec. It's going to fetch everything it needs just from this one page. It's kind of like the AI web page. That's why it's all matrixy. So it's very, very useful. And just give that to your AI. You can also install like the skill if you want. The skill is right here. And it's all here. You can copy and paste it. It's also available, I think, like this, skill.markdown. Yeah. So oneclaw.xyz/skill.md is the entire skill file. That's also very useful if you want to add that skill. I think everybody's probably using AI these days, so it's going to help you a lot, especially with troubleshooting. But let's log in real quick and just take a look here, and we'll try to build something. Okay, so you can sign in with Google, or you can sign in with, you can create your own account. You can also sign in with a passkey, which is also pretty cool. So it's really whatever is easier for you. I'm going to log in as OneClaw AI, and we're going to go here and take a look at what we got here. So when you first log in right here, you're going to see that we have Get Started, and it's going to walk you through kind of like creating your first agent, creating your first vault, and then sharing the two, because that's kind of the concept, right? You have agents, you have vaults, and then you have policies to share those things, right? So if we come over here and say start vault setup, we can do it. I'll do it by hand here so that you guys can see what it looks like. We'll call it example. And here's where you get to choose what kind of a vault you want. So do you want to do the standard one, which is just, HSM? It's pretty much good for everybody. 2 of 2 is only for pro users, and these are for business, like enterprise kind of clients. I'm going to give everybody on this call a free pro account. I'll give that to Zara, and she can send it out to the email list so that you guys have it. So everyone will be able to use the 2 of 2 if they want, but we're just going to do a standard just to show that off. Everyone will get 6 months of pro, okay? And then now we're going to store a secret. So we'll call it an example secret, and we're going to choose a path, okay? The path, you could kind of think of it like folders. Like you want to store a secret in a certain path. If it's an API key, you put it in an API key kind of path. If it's a password, you put it in a password path. It's really up to you. It's up to you how you want to do it. I'm just going to say password/example like this, and we'll choose password, and we'll put a password here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't use that as your password, but that's just for the demo. We're going to store that password. We don't need to save it here. And now we're going to register an agent. I'm going to create an agent. We'll call it example agent. And we'll call it, this is my AI buddy, and register the agent. Now we have the agent set up. It's going to register it. It's going to give us a agent ID and an API key. This is the most important part. The API key, you can only access it one time. Save it somewhere very in an encrypted env file, preferably in your project, or write it down or put it in like a password manager that's on your thing, because you can always rotate it, so it's not the end of the world, but you should save it. Okay, so I say I saved the key, and then now what we want to do is grant access for that agent to access the vault we just created. So we're going to grab it and say grant read access, and that's it. And then it gives us these little like commands that would let us really quickly test our agent, okay? But we'll just go to view agent so that we can see what you can do from here. So now this example agent has access to this example vault, and inside that example vault, we have an example secret, right? We can see it right here if we expose it, okay? And so we've basically have created a role-based policy and an agent for this agent. So if we go back to agents and look at the agent, this is my AI buddy, here he is, it's an API key, and now we can like fine tune what that agent has access to do. And by the way, all this stuff that I'm showing you is all programmable using API keys or using the SDK. Again, there's a concept of a human key and an API key. So obviously creating policies, you need the human key. The human key you get right down here on the bottom, right here where it says API keys, and we can generate a new one. So this is like a personal API key. But if we go back to agents and look at this agent, then we can see what can we do. Well, there's a lot of cool stuff that we do. One thing we do is we generate an identity for every agent. So what's cool about that is that you can do things like do attestations or like proofs using an existing key that's tied to this agent. It's kind of like the agent's identity, right? Like it's almost like its passport, right? So there's two kinds of keys. There's a signing key, which lets it prove things and sign to do identity verification. And then there's an ECDH key, which is good for cryptographic key exchange between two agents. So let's say you have two agents you've created through OneClaw. They can securely communicate over the internet anywhere in the world using their ECDH key. So that's really cool. They can also, again, prove things. Like maybe they want to prove that they are in a certain IP address and they could sign some kind of output from their console or whatever it is. You can use this kind of thing to sign something. And these are stored in the HSM. So they're secure. You can see there's no private key. We could reveal it right here and see what it would look like if we wanted to, but we won't do that. Smart accounts aren't necessarily working yet. Those are something that's coming soon. So I won't get into that too much. You can adjust the TTL of the token and how long it lasts. You can enable the shroud here, right? The shroud LLM proxy, which is all the security stuff that we talked about. And you can edit the configuration for it. And you can fine tune all of these things. Like maybe you only want this agent to use OpenAI, right? And you only want it to use GPT 4.0, right? You can create this custom rule, and anytime it tries to use Gemini, it would just fail. It would say 401 or actually it would say like 405 or something like that. Or you want to deny a certain model, or you want to only allow so many tokens to be used. So like maybe you want to restrict how much LLM usage. A lot of really cool stuff you can do here. You can redact the secret. You can check for Unicode data and normalize it. A lot of different stuff you can do here all through this kind of UI. I'm not going to go through everything, but you get the idea. And then you can enable certain policies like secret injection detection, output policy, whatever it is you want to do, very customizable. You can also create custom signing keys for each agent. So we support 6 blockchains: Ethereum, Bitcoin, Solana, XRP, Cardano, and Tron. And we're adding Midnight, and we're adding Ripple, and we already have Ripple. And we're going to be adding more here. But these are like essentially signing keys that allow your agent to make crypto transactions. So if we generate an Ethereum key here, it will instantly have a wallet. That's it. Now it's got a wallet and it's got a QR code, and I could use my phone to send $1 here. So very, very easy way to just give your agent a wallet. That's it. So now this agent, if it wanted to, it could sign transactions. And you can also, we have some other cool integrations. We have an integration with Banker. We have an integration with Anthropic to share your Anthropic key through certificates, through a certificate exchange. You can enable that, which is pretty cool. So that would be allowed to, that would let your agent use your Anthropic account, which is kind of cool. Like we want to basically allow your agent just to, not have it have its own API key for the LLM. So really, really cool stuff. So there's a lot of stuff here. I'm not going to go too much more into this. Let's actually try to build something. So I'm going to show you a really, really quick way that you can build out an AI agent with OneClaw. And it's using the scaffold agent that I talked about earlier. Okay, so let's try to do it real quick. We have this npx scaffold agent at latest command. Okay, so I'm going to grab that command here, and I'm going to open up a new chat window. Hopefully you guys can see this window pretty good. And we're going to run this command, okay? What's cool about this command is it's going to allow us to bootstrap a web application that is powered by OneClaw and powered by your whatever LLM provider you want to use. So we're going to call this one example. It's really boring, but we're going to call it example. We're going to say, yes, we want to use OneClaw for secrets management. You could use a basic environment variable that's encrypted, but then you wouldn't be using the cloud HSM. So if you're doing local development, you can do like this one, or you can do a plain ENV. It's not recommended. But if you're going to plan to take this AI agent and put it on the internet later, using OneClaw is recommended, right? And it's a secure way. So we'll use that. And then it asks us if we want to add our API key. So let's do that. We'll create that now. And we will load up my other account with OneClaw here. Let me load it up here. Let me sign in. So we're going to go into OneClaw and we're going to get a human API key because we're going to use the human API key to generate a new agent. Okay. So I'm going to come over here and say new API key. And we're going to call this example. Boring again. We're going to rotate this key. Normally, you wouldn't want to show this key on screen. This is tied to your account. This is something you would keep secret, but I'm going to rotate it anyways. So I'm going to add it here. And it wants us to set a password. So now I mentioned this earlier. Anytime that you're storing an ENV file that is a secret, it should not be in a .env unencrypted. It should be in a encrypted ENV. So it's going to tell us, do we want to secure it? We're going to say yes. And we're going to put a password. Well, actually, we're not, it doesn't even ask us. We have to put a password. So I'm going to put password. Don't use password as your password, but I'm just going to do that for the demo. And then we're going to generate a Ethereum address for this as well. Yes. It's going to ask us if we want to use ampersand. That's like an X402 thing. I'm going to say no. Then it's going to ask us what kind of an LLM provider we want to use. Okay, so OneClaw also is an LLM provider. So what that means is you can bill all your LLM through OneClaw. But we're going to use OneClaw, and we're also going to use OneClaw for our billing. But you can just choose what you want to do here. If you want to protect your LLM, you need to choose Shroud here, right? The stuff that we talked about earlier, we want to do that. Where the LLM is actually talking is really up to you. You can use OpenAI, Google, Gemini, whatever you want. I like Gemini. It's got a pretty good LLM. And then it asks us how we want to handle our key, because we can either provide our own API key or we can use OneClaw. What's nice about OneClaw, again, is you can just have everything through OneClaw. So your agents, your secrets, your billing for your LLM, and then you don't need to have an LLM private key that you manage with, say, OpenAI or Gemini. So we're going to use OneClaw. Then we could also build an agent that has smart contracts. For this demo, I'm not going to do that. But let's say you wanted your agent to have a starting smart contract that it would use. You could build that here, and it would ask us what chain we want to use. So if anyone's not familiar with that, Foundry or Hardhat are kind of the main options, and you could choose that. I'm just going to say none for right now. Then it asks us what framework we want to use. We're going to choose Next.js because it's just easier. And it asks us if we want to enable the TEE transaction signing that we talked about. And so we'll say yes. And that's it. So now it's going to bootstrap an AI agent. It's going to install all the packages. So Next.js, it's going to install, the wallet connection stuff. It's going to install the OneClaw SDK, and then it's going to wire up all the secrets. So what's cool about this is all the secrets are going to be stored in OneClaw. So if I come back over here to OneClaw and I go to agents, you'll see that I have an example agent. So it automatically created me an agent, and it automatically created me a vault. Let me make this wider. So you can see here we have an agent called example, and it already has a policy. It already has the Intents API enabled. It already has the Shroud enabled, right? Because we do it all programmatically. And it automatically creates a vault. And it automatically stores those two keys. It stores an agent key, so it's an Ethereum key, and a deployer key for the smart contract. And we could add more secrets. Like if we want to give our agent another API, let's say we want to give it a Stripe API key. We could come in here and add it, and then that agent would instantly have it. So that way you don't have to deal with like an ENV file stored locally on your machine. It's only through, it's kind of like 1Password, but way better. Okay, so now it's done. It installed. And let's see here. Now we can just start it up. So we go into example and we go to just start. And it asks us for the password. And now we have the password in there. And now we have a full stack application. So let's just try to talk to it real quick, okay? So let's load it up. And fingers crossed that it works. There it goes. So now we get this kind of like cool little chat interface. And we can be like, hey, what is pi to 10 decimals? So at this point, it's going through Shroud. It's making sure there's no prompt injection. It's making sure that there's no malicious content. You know, if I was to ask it a more complicated question that maybe was like malicious, you know, it's probably going to freak out and give us an error and not work. And that's kind of the benefit here, that we've kind of bootstrapped an agent really quickly using AI and using, and then you'll see here we have like a wallet that we can connect to. So we can connect. So Scaffold ETH comes, or sorry, Scaffold Agent has this burner wallet functionality. Oh, it's kind of weird that it's not there actually. Oh, something's up with the burner wallet. You can see here we have MetaMask connected. We can connect to MetaMask. Oh, it doesn't have the burner wallet because we didn't choose a chain. But if we decided to choose a chain, it would have come with a burner wallet. But you can connect to MetaMask or Rainbow or whatever wallet you want, just like this. And what that does is it gives because your agent has a address here that's saved. Again, the private key is saved inside of OneClaw, but then we also can interact with our agent with another wallet. And so that's what this wallet is. And so this wallet is stored inside of our browser session. It's not inside of OneClaw. And then we have these tabs up here, which are really cool. So you can see how quick it is to use OneClaw programmatically to like start building an AI agent. Another use case would be using the CLI. Now, oh, this is not the one I need. Where's it at? Let's see, go back here. So the CLI, and I'll just talk for 5 more minutes about the CLI and then we can see if there's some questions. What I like about the CLI is it's got 2 commands that I want to talk about. The first one is OneClaw setup. What's cool about that is it's going to automatically create and configure all of your AI clients to use OneClaw. So let's say you are using Claude Code or Claude Desktop or whatever, or all of them. You can just run OneClaw setup. It's going to let you log in, and then it's going to automatically configure all the configuration files for you. And then all you need to do is restart them. And then you'll instantly have access to your OneClaw account. Very easy to do. The last thing that I just started working on today was this other cool idea where you can just run this one single command and it will spin up a OneClaw powered AI agent locally. And it's similar to what I just showed off with Scaffold Agent, but it's a little more lightweight and it uses Docker instead. So the one that I showed you here is all running locally. This will be kind of the next thing that we'll start doing. And what will be nice here is eventually OneClaw will also be a hosting tool. So you'll be able to take your AI agent and host it through OneClaw as well. And so right now we can just do Docker local, but coming here soon, you could run it in Docker, or you can publish it to the internet using OneClaw as well. So OneClaw will kind of be like an AI agent hosting platform as well eventually. So really cool stuff. The CLI is very thorough. You can do anything you can do through the UI, you can do with the CLI. And very powerful. So you can see there's lots of settings in here. So I highly recommend using AI as much as possible to kind of to figure out what you're going to do, because yeah, obviously there's a lot here. Let me show a couple other things real quick. I guess there's also a risk engine which will keep track of AI agents accessing your secrets. And let's say that you are in California and you've deployed your agent in California, and then you're like operating and you've given your AI agent access to your Ethereum key, and then all of a sudden a user comes in from Russia and tries to access the JSON web token that you had issued for your agent because you somehow did not realize it, but your computer was hacked, the risk engine will just disable the agent immediately. So that's super powerful because you can kind of predict what your agent is accessing and then just automatically cut it off. We do that by default. We also have these honey tokens where you can create like a honey, we call them honey pots in security. And they call them honey pots because if you stick your hand in the honey pot and you get stuck and you get caught. So we have the same thing. We can create a honey pot in a vault and we can say, yeah, credentials / AWS master key. And we can say a master key for AWS for all users or something like that, right? So if a hacker got access to your actual OneClaw account and tried to access this secret, it would immediately lock your account. So we have some really cool stuff that is very, very security focused and to really protect you as a user and being able to not have to worry about security while you're building, right? And just kind of build. And so one thing I want to talk about again is OneClaw is free, so anyone can use it up to 1,000 requests a month. Again, I'm going to give, sorry, my computer's, I'm going to give everybody a pro account here today, and the pro account will be good for 6 months. That'll allow you to do up to 10 agents, and yeah, have more vaults if you need, up to 20,000 requests for you guys to use it. I want to see people building on it. I would love to see what you guys build. And if you build something cool on it, please let me know. I'll help market your stuff for you. I have a pretty big reach. And yeah, thank you so much, guys. I know that was really long, so thanks everyone for sticking with me. Okay, cool, we got questions. This is awesome. If the API key got copied and we need to stop it on one side as a way to control access, once they got copied once, does it stay persistent in some obscure corner of the LLM cloud? No, it's discarded instantly in the LLM, in the shroud. So we use it at the time, runtime, and then it's discarded. We don't do any logging of sensitive data or anything like that. When I create an agent in OneClaw, does the agent automatically get registered in ERC 1004? That's a great question. Not yet. We are working on some stuff for that. We're just kind of waiting the entire thing out because ERC 8004 is rather new, and there's other ways you can do it pretty easily, but we're going to add that stuff soon. Can you share this video so I can literally try to recreate the thing you did step by step? We have another one, Nadia, and like another video where I've done this, and I'll try to send it out to so that you guys can have it. I'll try to get the email list and we can send it. And yes, we do connect into Banker. We have a way where you can use, like, let's say you don't want to use the Banker UI for your chat and you want to use their API key system. We have a way to issue like rotatable keys through the Banker thing, and so you can integrate it there as well. When I store passwords for encrypted DNV, do I use 1Password, or is there a smarter way? I mean, that's an option. I'm at the you know, like even me as a user, I need to store secrets, right? And so I do use 1Password for some secrets, but I just make sure I have 2FA on them and I'll use it. So yeah, 1Password works for that other secret if you really don't, you know, yeah, you don't want to store it in OneClaw and you want to maintain two kind of custodies, that's fine. It's kind of ironic that like I need to use 1Password when I need to create OneClaw. How do we increase the accuracy of the agent? So yeah, I think that's more like LLM tuning related stuff, if that's what you mean, Sai. But I'm not sure that OneClaw really helps with that. We're really focused on security and less on the logic of the agent. What is the source? Is it web, or we have to submit the data to it? I'm not sure I understand that question. Maybe you can clarify, Sai, on what you mean by the source. If you mean the source code, yeah, I don't know, maybe you can re-ask that question, Sai, and explain. Another question, is OneClaw actually basically okay for else or humans to store seed phrases and private keys? That's a great question. Let me just share my screen one more time, and I want to show off another thing here. So OneClaw is also a we have treasury wallets. You do need to be a pro customer or above. Let me log into my other account here and I'll show you what they look like. We're similar to like Fireblocks. I don't know if anyone's heard of Fireblocks before, but we're also very similar to Fireblocks in the sense that we have, because we store secrets securely, we can also store embedded wallets, right? So we do embedded wallets. So if you want to replace like Coinbase embedded wallets, you can do that with OneClaw. Let me log in here real quick and I'll show you. OneClaw. Go 402.436. Okay, so if we go here to Treasury, and we can see what that looks like. But we have Bitcoin, Cardano, Ethereum, Solana, Tron, and XRP wallets. And if you create one, you can essentially copy the thing here. You can receive crypto directly to it. You can export the key. You can rotate the key. You can see here I have some ETH in this one. And we can also do deposits, have deposit addresses, unique ones, which are, a way for you to just accept crypto, maybe from a certain client or something like that. We also can create separate accounts. You can see here where we've created a lot of different accounts for testing. These are unique accounts, so you can create additional ones inside your org. And for safes, we also support creating multi-sigs through here. You can either create your own through here, or you can register an existing safe. And your AI agent also can request access to your safes as well. So like, let's say you have a multi-sig that's got 10 ETH in it, and you want to allow your AI agent to be a signer on that multi-sig, right? And maybe it's a 2 of 3, right? And then you could be the authorization through here, and then you can allow your agent to sign and request. So we're going to be adding a lot more to this stuff. Right now it's kind of lightweight, but that's kind of where we're at right now. Good questions, by the way. Let me find out. Let me turn this off. What else we got? With the risk engine, when somebody is in another country, as I said, without my permission, is there a way to see it and visualize it when it's happening? You'll be able to log in and see it. It's not like a real-time thing where you could see, but you'll be able to see all of the access. And we're using like the IP database to like determine where the user is coming from. The minute it's from a different country, we just kind of like disable that agent. And so you'd be able to see right there when the agent was disabled. Kevin's excited to see what we can build with AI agents. Thank you. As a student who loves experimenting with new ideas, how do you balance the speed of testing fun, creative ideas while keeping security in mind from the start? Well, that's why I built OneClaw. I mean, it's kind of the reason why I built it is I was starting to build AI agents for, Spritz, which is my chat application that I just built. And I started to realize that this was a huge problem and no one was really making it easy for AI agents to operate safely. And so, yeah, I think it's a good start for you to use, OneClaw. And then what I always recommend is whatever project you're doing, like set up a weekly kind of audit that happens on your code base where you're constantly auditing, constantly fixing things. Also, try to work with other, people that are testing stuff to try to find bugs. And, sometimes it requires a little human touch, but we're getting better. I think with AI, it's getting cheaper and easier to build stuff, and it's going to get better as we go. How to get data for the work we provide? Is it web, or we want to give data with the work to do? How to agent get data for the work we provide? Is it web or we? I'm not sorry, I don't understand the question. Can we interconnect up to 4 agents and make them think step by step? So yeah, it's a good use case for agents. I mean, Google A2A is the framework that I would recommend for that. It's got some built-in like kind of multitasking stuff. And we have a starter kit on the GitHub that shows you how to build a Google A2A agent using OneClaw and using encryption. So I would check that out. It's on the GitHub for OneClaw AI. Can we interconnect up to 4 agents? Oh, that was I already asked that one. This one's about to end. Okay, cool. All right, I think I got all the questions answered. Any other questions? Those were really good questions, though. That means that everyone was paying really good attention, so I appreciate that. We have 4 more minutes. Any more questions? Any questions from you, Zara?
Good on my end.
Awesome. What is the
Oh,
skills we want to learn for ML engineer? I think for machine learning, I'm not an expert there because most of what I work on is in the infra space. But I think for getting very comfortable with data analytics, and then the pivot to machine learning is pretty easy. I think it's just more learning how to train models and stuff like that. Yeah, I'm not an expert. Probably getting very hands-on with like local models and figuring out how to retrain those. That would be an interesting thing to try. For an AI engineer, it's learning just in general how LLM APIs work and stuff like that is kind of the core stuff. Cool. Thank you, Zara.
thanks so much for joining. We have one more question, I think, from Nadia.
Yes, that's a good question. Do we still need hardware wallets? Absolutely. We're working on an integration with Ledger, actually, where wallets are going to be a very important key to using the agents, knowledge and access to OneClaw, but doing like hard approvals through like a Ledger signed device, which is quite interesting. So yeah, I think hardware wallets are still a thing. We're going to be adding in a lot of stuff for like Ledger and some of the other hardware wallet vendors into the treasury stuff. So yes, you still need a hardware wallet, but I think for like giving access to an agent, most of the time, I think an HSM is more viable because it needs to be like more of a hot wallet. Awesome. Well, thank you so much, Zara. I really appreciate you having me. Thank you, everyone, for tuning in. I will get you that code so you can send it out to everybody. And I really want to see what people build. So build something cool for me and show it off. Ping me on X. I'm cryptomastery_ on X. And there's a link to my Calendly on the website for OneClaw. Feel free to schedule time with me if you have a question or want to show me what you built. I would love to see it.
Cool. Thanks so much for joining us, Kevin. I hope that everyone learned a whole lot from this session. Today was a great turnout, and a lot of you have stayed right until the end, which is amazing. So thanks so much. Hope you guys learned a lot. We will be sending all the links that Kevin mentioned earlier. So do stay tuned for that. We also have a couple more AI sessions happening at the end of this month. And I saw a couple of questions on AI skills in jobs and that sort of thing. And interestingly enough, we do have a podcast that we are launching, which will be focusing on these very specific areas. So do stay tuned. There is a whole lot that's coming. Sai, to answer your question, do keep an eye on your inbox via email, because all of these will be coming via email. So basically, if you have signed up for the session through Luma, we have a registry of your emails, and we'll be sending all of the links through that. All right. Thank you guys so much for joining. Kevin, a pleasure as always. Thanks so much. Looking forward to meeting you again, and looking forward to hosting everyone else again as well. Have a good day, guys.
See you guys. Thank you so much.
Thanks so much. See you.
Bye.